Alright, we're going to look at an example of solving a separable differential equation.
Hot stuff coming up.
Yes, very hot stuff. So everyone get ready and...
focus.
Good. So, here's our linear first order differential equation. Actually, you'll learn in section 7 you could also solve this as a linear first order, but that's beside the point for this one. I'm going to show you how to do this one by separation of variables. First, subtract this from both sides, right? That shouldn't give you too much trouble. Then divide both sides by y, multiply both sides by dx. That's an interesting benefit of using this notation because we can actually treat it like algebra.
And?
Well, I mean, we treat it like algebra and put the dx as a multiplier on the right-hand side.
And?
Well, and then we have the left-hand side and the right-hand side separated in that the left-hand side only has y as a variable and the right-hand side only has x as a variable.
And?
Well, you see on the left-hand side now we can integrate dy over y, which is an easy one, ln absolute value of y, and integrate on the right-hand side negative 2x. Of course, that's an easy one. It's just negative x squared over 2. I'm sorry, just negative x squared. Plus a constant c. That constant covers the constant of integration from this side, this left-hand side, and from the right side. They're added together. Now, here comes a very crucial thing where a lot of people make mistakes. So I'm doing this to try to help you.
How dare you?
Well, I'm doing this because I've seen so many people err here. I've seen so many people make mistakes. Now, in order to solve this explicitly, we would have to solve for y. Well, we got ln of absolute value of y here, and that's not what we want. We want it to be y.
I can't wait.
Well, we're getting close, but the idea is, if you make both sides of this equation exponents for e,
I don't understand.
well, that's just one of the manipulations you can do with equations. You can make them both exponents for the same base. So we'll choose e since this is ln. So e to the ln absolute value of y equals e to the negative x squared plus c. Here is this crucial step I've been saying about. Well, of course, e to the ln of y is just, or ln of absolute value, y is just absolute value of y. But e to the negative x squared plus c is e to the negative x squared times e to the c. Refresh your rules for exponents if you're struggling with that. Here's what I'm telling you. X squared times x cubed, you should all know, is x to the 5th, right? So you add the exponents. When the exponents are added, the factors are multiplied, right? I'm using maybe a backwards version of this rule for exponents here, so do be aware. So this is times e to the c, not plus e to the c. So e to the c is just another constant. Call it c. And since c is arbitrary, when we say absolute value of y equals this arbitrary constant times e to the negative x squared, or c could be positive or negative, and that takes care of the absolute value stuff. So here we have it solved explicitly, whoops, with a mistake. Y equals c e to the x squared. And that is what we needed to discover here. We have an explicit solution.
Okay.
And it's solved by separation of variables and, of course, integrating both sides. And being extra careful about how we went from this step to this step. Do you understand that?
Okay.
Great. So you won't make that mistake yourself.
Oh, yeah?
Well, I hope you won't make that mistake yourself.
Oh, yeah.
Okay.